I'm pleased to introduce Mr. Anish Pandari, the current Director of Product Development and Strategy at Indxo AI Private Ltd. He initiated his professional journey at National Instruments. His career path spans diverse technical and marketing roles, culminating in his present leadership role. During his tenure as Director of Product Development at Electrono, Anish played a pivotal role in spearheading smart factory transformations for industry giants like Honda, Toyota, Mahindra, Hyundai, Bosch, and others. His background in computer science is contemplated by an executive master's from the Indian Institute of Management, Calcutta. Furthermore, he holds dual master's degree in management from All India Management Association and Christ University. Today, Mr. Pandari will talk on quality in AI and IoT integration for smart factories. Please join me in welcoming Mr. Anish Pandari.
Like the slide my predecessors showed, we are talking about the evolution from the Industry 4.0 standpoint. What we notice now is the kind of change that is happening. Earlier, it used to be, if you look at it, it is that century, this century. Now it is in decades. The change is happening in decades. Like, for example, we are already talking about Industry 5.0, which is, bringing in the complete sustainability aspect also. So right now, as we speak, the Industry 5.0 becomes the new norm, and so we believe that these changes going forward will be even rapid, and that is all got to do with this huge data that is coming to play, and the kind of kind of information that we can derive out of the same. So when you talk about Industry 4.0, if we go dwell a little deeper, these are the critical elements of Industry 4.0 that we look into, wherein the basis of most of it forms the IoT platforms. The IoT, where the ability to collect data from the shop floor. When you talk about shop floor, it consists of production machine, the CNCs, the PLCs, the sensors, the quality, the CMMs, the gauges. The ability to connect data is the most critical scenario here. Once this is where most organizations fail. They either are not able to get data from all these places, because obviously in a shop floor you have all kinds of machines, right? You have from the CNC side itself, you will not have just Fanuc, you will have Siemens, you have Mitsubishi, Mazak, Heidenen, Haas, right? You have so many different kind of CNCs. PLCs, again, similar, Rockwell, Siemens, Mitsubishi. And sensors, again, multiple times, and similar to the CMMs, you have the Zeiss, you have the Hexagons, you have the Mitutoyo, you have a lot of other digital quality machines and quality equipments that are there in this. Ability to connect data itself is a big area. And once you collect the data, then comes the biggest hurdle in the next area, where is the ability to assess this data and to make logical or meaningful sense out of it. And this is where, again, most of them fail, because, to take informed decision out of something as complex as machine data is again, not, easy. So this is, again, it is important to be able to understand that you have the strong foundation that is laid. The kind of data that you are gathering is the foundation on which you will be building your next digital twin or AI. So ensuring that the foundation is strong is the critical area again. So we have seen many of our customers where they say that, if a certain data is not available, they say, why don't you fill it up with AI? The whole point is that AI, cannot be a substitute for, most of these building blocks. So AI, in terms of our old saying of how the computer was, it is garbage in, garbage out. You are able to provide validated and authenticated data. You are able to receive that kind of relevant output from the AI algorithms. So moving on, again, you have the autonomous robots, the cybersecurity, cloud, augmented reality, and additive manufacturing. These are, again, some of the critical elements of Industry 4.0. I will not dwell into all of them. These form the crux of Industry 4.0 for us. From these elements, what happens is, now as a a consultant or advisor, whenever somebody asks us where do we start, right? Industry 4.0 itself is such a huge gamut. And the confusion literally starts as to where do we start. So this is kind of a blueprint that we propose for an organization which is looking to move into the complete industry 4.0 gamut, is how do you lay a kind of blueprint for them to move into here. Because unlike most of the US or the European customers that we deal with, India is a quite a complex being. Again, it is not any different in most of the international markets as we think. Most of them are in the similar space. Most of the challenges that the international customers face are similar to what we have in our home. In fact, I feel that in some areas we are much better. So we start off with the Gemba in terms of to assess the complete gate in to gate out, understanding the complete shop floor to top floor, understanding which are the areas that will need to have the digitization element, setting up the objectives in terms of what are the areas that you will actually need to digitize, or where are the elements that can provide that kind of impact. Then move into solution engineering, and then the critical element of digital infrastructure. Most organizations look at, sometimes when you look at a very large high level thing, sometimes we miss out on very basic elements like the digital infrastructure. Simple thing as an industrial wiring can make a difference in these aspects. They say that we have implemented the most costliest software, but the software is a failure, or they talk about the implementation failure. What happens is, we need to know that all the some of these OEM giants have invested huge amount of R&Ds, and these kind of softwares are literally state of the art what are available. But to be able to gain or to get the maximum out of these, you will need to also ensure that these foundations are taken care of, right? Simple sometimes a short or cost cutting in terms of cabling will ensure that you don't even have the relevant data passing to the system. And then to expect a positive outcome out of it is next to impossible. So these are small areas that people see that, okay, might not make a difference in terms of cost cutting, but those kind of areas have huge impacts on the outcomes. Further moving on, we go on to the process optimization once you have the basis form, and then we suggest going for the ERP or the digital twin as the next stages. So this is a basic flow of how we go in terms of the blueprint. Now, if you pick up from the manufacturing side, I have picked about four most common areas and departments that in the shop floor that we try to work very closely with. One is the production shop floor, where most of them want to know what is happening about their production without any human involvement. How do you get what is happening in the shop floor without any human involvement? So these are some of the parameters, again, the OEE, the energy analysis, tool life monitoring, etc. from the production side. Similarly, the maintenance, how can you have relevant predictive maintenance? How do you have those kind of real-time alerts to the system where people can ensure that they have a smooth functioning without any downtime in their shop floors? Quality, again, like I will mention, the complete CPCPK, PPK, the complete shop line level tool life assessment, etc., is a very critical aspect. And finally, the skill safety, which goes without saying. Skill level of the employees play a significant role in terms of how that needs to be assessed and improved in terms of the outcomes. And safety, the cybersecurity and environmental safety becomes another critical element of this bucket. Moving on, as my topic concerned, I will be sticking to quality as part of one of the elements, right? So when you get into quality as one of the elements from the entire gamut of the shop floor, the critical element that comes is again in terms of the yield or the throughput. So it's again measured in terms of from the good parts that are produced minus the kind of bad parts. The bad parts are further divided into two. It's again rejection and rework, right? Now, these is the complete cycle in which the quality works. And there's four critical elements: the man, machine, method, and material, which forms or which influences the output of what comes out of this particular system. So these are the areas which in terms of have a, interference with what is the output. So in terms of the kind of output produced, the throughput, which is the good parts divided by the total number of parts produced, would give the throughput or the yield percentage, which is the calculation to understand how how good your performance is in your particular organization. Now, moving on, these are the various factors through which all these elements influence the quality or the output of the particular system. When you talk about man, like I mentioned, the skilled workforce plays a critical role, the training certifications of the people, the human expertise, etc. And when you talk about machine, the state-of-the-art equipments, what kind of equipments are you using? Those play a critical role, the monitoring, automation, and the maintenance and the calibration of the systems, right? All these are critical to ensure that you, from the machine side, you are able to produce the relevant quality output. The methods, as you know, this is probably something which is, been there for the longest of, we always talk about the quality control methods, the Kaizens, the, Six Sigma, the total quality, management. But how does, the whole thing is now with the digitization, these are now implemented with a renewed zeal, because earlier it was not, we were not able to implement the methods properly. The next step, I will tell you what was the reason for the methods failing in some places, and what is the, how can we ensure that we can do it better. And finally, the material, obviously the raw material quality, supplier evaluation, and material testing, etc., plays a critical role again in terms of from the quality aspect. So we've seen that in methods, a lot of areas or places where it fails, and what is the reason for it to fail. And that is because what is not defined cannot be measured, and what is not measured cannot be improved, and what is not improved will always degrade. The whole concept of continuous improvement. And here is the critical element of measurement, right? In the previous methodologies where we were talking about a lot of TQMs, but the whole concept of real-time measurement, which was lacking, was one of the reasons for the failures of most of these kind of methods. Now with improved methods or measurement methods, we are able to bring about significant changes to this, and right now able to provide better quality outputs in organizations. So just to touch upon the kind of yield analysis that we end up doing in terms of, these are some of the dashboards or real-time dashboards where we would be able to track real-time yields, which are again shift wise. You can look at it at the total yield. You can look at it, the complete real-time failure analysis, what are failing, which parts inline, like Avin sir mentioned, the real-time quality, real-time inline quality, as well as so that you can take real-time correction, so that you don't have to wait for the entire part to be checking the quality and then ensure that see to it that there's a lot of wastage of time. Real-time correction, real-time alerts to ensure that these things are taken care of. These are some of the dimensional reports. Like for example, one of the customers that we work with have close to 900 parameters that they mention, that they measure. Right now, when you talk about quality, you can go to any amount of any depth to ensure that what is it that you want to measure. So quality, like I said, is an obsession for a lot of teams. It brings in a lot of brand value to the organization based on the kind of output that you are able to produce. So just touching upon some of these real-time screens in terms of the heat maps, that you can get, inspection overviews, the process analysis, you can get, different ranges by this. These are again some of the screens that we provide for various, quality outputs. The various process inspection, capabilities, the cross-correlation analysis, in process focus based on the the mathematical functions as to how you can ensure that there is less of anomaly and better outputs. So, and the prediction factors based on the previous quality parameters, how can you predict what would be the kind of yield that is going to come out. A very significant necessity for most of these shop floors, where they will need to understand what would be the predicted quality of the product that they're expecting as output.
Thank you, Mr. Pandari, for sharing your insights on quality in AI and IoT integration for smart factories.